welcome to Section 8, Lesson 7. The perfect square trinomial is the cleanest of the trinomial factoring patterns. When a trinomial is the result of squaring a binomial, you can recognize it on sight and factor it back into that binomial squared in a single line. There are two formulas to recognize. Plus form a squared plus 2ab plus b squared equals the quantity a plus b squared. Minus form a squared minus 2ab plus b squared equals the quantity a minus b squared. The only difference between them is one sign flip on the middle term. The recognition test has two parts. First, check that the first and last terms are perfect squares of something. Call those somethings a and b. Second, check that the middle term equals plus or minus 2 times a times b. If both conditions hold, the trinomial is a perfect square and factors as one binomial squared. Today's two examples cover the plus version and the minus version. After watching once, perfect square trinomials become a one-line factor that bypasses the AC method and saves significant time on tests. The two formulas appear stacked. The plus version says a squared plus 2ab plus b squared equals a plus b squared. The minus version says a squared minus 2ab plus b squared equals a minus b squared. They mirror each other across one middle sign. The first half of the test asks whether the first and last terms are perfect squares. The first term must be the square of something, call it a. The last term must be the square of something, call it b. If either fails the square test, the trinomial is not a perfect square, and you move on to other techniques. The second half of the test checks the middle term against plus or minus 2 times a times b. Multiply the two square root values you identified, double the result, and compare its absolute value to the absolute value of the middle term. The signs of the middle term decides which formula applies. If both halves of the test pass, the trinomial factors as a single binomial squared. Use a plus b squared when the middle term was positive, a minus b squared when the middle term was negative. One binomial raised to the second power, complete factorization in a single move. Factor x squared plus 12x plus 36. Run the perfect square test before reaching for any other technique. First and last terms first. X squared is the square of x, 36 is 6 squared. So the first and last terms the perfect square test with a equals x and b equals 6. Now the middle term test. 2 times a times b is 2 times x times 6, which equals 12x. The middle term of the polynomial is also 12x with a positive sign. Both halves of the test pass, and the sign tells us to use the plus form. Identify the formula to apply. With a equal to x and b equal to 6 and the middle term positive, the trinomial equals a plus b quantity squared. Substituting the values gives x plus 6 all squared. The factored form is x plus 6 the whole thing squared. One binomial, one square, one line of work. Verify by expanding x plus 6 squared back out and you recover the original trinomial. Example 2. Factor 9x squared minus 30x plus 25. Same procedure as before, just with a leading coefficient bigger than 1 and a negative middle term. First and last terms, 9x squared is the square of 3x, 25 is 5 squared, so a is 3x and b is 5, both pass the perfect square test. Middle term, 2 times 3x times 5 is 30x. The middle term of the polynomial is negative 30x with the same magnitude. The negative sign tells us to use the minus form of the formula. Identify the form. With a equal to 3x, b equal to 5, and the middle term negative, the trinomial equals a minus b quantity squared. Substituting gives 3x minus 5, the whole thing squared. The factored form is 3x minus 5, all squared. The minus inside the binomial reflects the minus on the original middle term. That sign correspondence is the visible signature of the minus version of the perfect square pattern. 3 takeaways for perfect square trinomials. They make the recognition test fast and the factoring trivial. The first and last terms must each be a perfect square. If the first term is not the square of something or the last term is not the square of something, The trinomial is not a perfect square and the pattern does not apply. Move on to the AC method or another technique. The middle term must equal plus or minus 2 times a times b, where a and b are the square roots from the first test. Compute 2 times a times b, then compare it against the middle term. Match means perfect square, mismatch means try a different factoring tool. The result is one binomial raised to the second power. The binomial uses a plus when the middle term was positive, a minus when the middle term was negative. One binomial, one square, one line of work. The cleanest factorization in algebra.